In this video, I'll present the paper titled Crystalline, Lowering the Cost for Developers to Collect and Organize Information for Decision-Making. My name is Michael Xieyang, and this is a joint work with Professors Kittur and Brad Myers. Developers spend a large portion of their time searching and making sense of the web for solutions to their programming problems. For example, to complete a high-dimensional data analysis task, the developer searches and browses the web to find out the different APIs to represent matrices in Python, and runs into all kinds of detailed evidence about these APIs. To help him visualize and inform a decision, he uses our previous research tool called Aniket, which enables developers to collect and organize information into a comparison table as they are searching and browsing the web, which is filled with the various options, criteria, and the evidence about their trade-offs. In general, there have been many commercial and research tools like Aniket that help people collect and then organize information as they find it while searching and browsing the internet. However, even with the above tools like Aniket, it remains a laborious process for developers to manually identify and capture the relevant content, keeping track of where it came from, and also synthesize it with other content. In addition, prior work suggested that people are often uncertain about which information will eventually turn out to be relevant, valuable, and worth capturing, especially at early stages of their learning and exploration when they're overloaded with information. Under these circumstances, people are hesitant to frequently pause and shift their focus from the investigation itself to reasoning about what to capture for later use. Another challenge is that sometimes the needs for collecting and organizing information are often not discovered until halfway through a project. For example, new external requirements and constraints could come in the middle of a project, or developers were unexpectedly asked to explain their decisions and rationale after the fact. It is hard and involves duplicate work for developers to recall and retrace their steps of sense-making and recollect all the relevant evidence again. In this work, we explore the idea of having a system automatically help users keep track of and organize information by leveraging the content they're browsing and the signals from their browsing behavior. In order to address the limitations of Aniket, as well as other similar sense-making tools from prior work, we formulated 3 design goals. First, the system should attempt to automatically collect information in the background without the user's specific attention or direction. This will help users focus on the main task of reading and comprehending the content. Second, the system should actively filter, organize, and prioritize the collected information that gets presented to the user and help the user avoid information overload. Third, in cases where machine support is undesirable or incorrect, the system should allow users to easily recover from those mistakes. Following these goals, we built a prototype Chrome extension called Crystalline. Crystalline automatically collects information snippets about options, criteria, and the associated evidence, which was reported by prior work as the key aspects developers look for when solving decision-making problems. As you can see, as the developer opens and reads web pages, Crystalline's sidebar on the left will be updated with the automatically collected options and criteria. Currently, Crystalline employs a combination of natural language understanding heuristics to recognize potential options or criteria in the web content, such as looking for a word or phrases between any instances of VS, and also running entity extraction on page titles, headers, as well as table headers. The list view of options and criteria serves as a concise and glanceable outline that reflects one's exploration progress. Clicking on one of the criteria will enter a detailed view for that criterion, listing out all the collected evidence snippets organized by options. Similarly, clicking on an option will enter the detailed view for that option, which lists all the related criteria and the corresponding evidence associated with that option. To collect the evidence snippets associated with the options and criteria, as well as automatically prioritize them, Crystalline tracks 5 implicit signals from users' natural browsing behavior: copying content, text highlighting, clicking, cursor hovering, and content dwelling, and translates them into numerical scores that approximate the amount of attention a user has given to a specific block of web content. For example, intuitively, if a user highlights or even copies a particular piece of content out while reading, there's a good chance that it is considered more important than other content on the page. Developers can also switch to the comparison table view that summarizes the decision-making space and the trade-offs among various options in detail. The order in which a criterion gets presented, both in the list and the comparison table view, are based on the estimated importance of the item to the user, which in turn is derived from the user's implicit behavioral signals when browsing. Of course, to correct machine mistakes, users can always pin or reorder these criteria manually. So that was a high-level walkthrough of the system. For evaluation, we conducted a lab study to understand how well the combination of natural language understanding heuristics and browsing behavior signals perform in terms of automatically helping developers collect and organize information from a given set of web pages into a comparison table. We found that participants were able to finish tasks significantly faster using Crystalline, and in the meantime, using Crystalline incurs much less overhead cost, which means that participants were much better able to focus on reading and comprehending the actual content rather than spending the extra time collecting and organizing information manually. As a proxy of table quality, we evaluated the correctness of Crystalline's automatic approaches by how much editing people had to do to fix Crystalline's mistakes. We found that participants only had to perform on average about 12 edits to the automatically generated tables, which is significantly fewer than the 51 actions that they had to manually perform in the baseline Unicode condition, suggesting that the quality of the resulting tables did not degrade too much, as was seen in previous automatic approaches. Participants also provided positive feedback to Crystalline, such as, "It feels as if I was sitting in the passenger seat and not having to do all the steering and maneuvering while reading and processing the web pages," which underlines the value of our approach. In addition, even within the short time frame of the study, participants also learned to accept and work with the occasional unhelpful machine suggestions. So to conclude, it is possible to automatically identify and collect information from web pages that a user is browsing using a set of natural language understanding heuristics. In addition, implicit signals from users' browsing behavior can be captured and analyzed to prioritize and filter the automatically collected information. For more details on the design, implementation, and evaluation of Crystalline, please read our paper or email us to get in touch. We really appreciate it. Thank you.